All right, so the next part of our polynomial functions is needing to find zeros. So we've already done the end behavior, so we know what it's going to look like at the ends, but the zeros, which are where it crosses the x-axis, will help us figure out some more key points on our overall graph. We're also going to go over some sketching. We're actually going to save the sketching for in class. So make sure you leave room. We're going to do about 3 graphs in class just to kind of introduce the sketching part. What I want to focus on in these notes is the finding of the zeros, as well as writing equations given zeros. So being able to go both ways with that. So one of the things that we're going to do to find the zeros, so our directions here are find the zeros, and state multiplicity. So multiplicity is when we get the same number more than once. We say we get that multiple times, and multiplicity is just a word that we use to state how many times we get the answer. So our zeros, if we remember, are just our x-intercepts, and in Math 2 you learned a lot of ways to find them. And I know you continued that in Math 3. So if we start with our function, and we're asked to find the zeros, that was when we had to set our y value, in this case f of x, equal to 0 and solve for x. So how do we solve for x? Well, we could factor, complete the square, quadratic formula, or square roots, all depending on the type of problem you have. So the easiest one is factoring if it's something that's factorable. So when I look at this, I can do a double bubble factoring, x minus 4, x minus 4. So then when we actually solve for x, we'll have x minus 4 equals 0, x minus 4 equals 0, giving us 4 for both answers. So because we got the same answer twice, we would say in our final answer that x equals 4 with a multiplicity of 2. And usually we abbreviate that so multiplicity of 2. The multiplicity is going to help us when it comes to sketching. That's why it's important that we know it. So for right now, we're going to write it. Do you always have to write it? No, but for the purposes of what we're doing right now with our sketching, it's really helpful to have it written down so we can use it later. Okay, so let's try another equation that we're going to again find the zeros on. And this one we're going to do fractions, just because fractions tend to scare us. So we're going to do one with fractions so that we can approach our fears. So just like the one before, we start by making y equals 0, or in this case f of x equals 0. And then I'm going to look for a GCF. So what's something that goes evenly into all of these? Well, I can take out a 1/5 x. Now when taking out a 1/5 x, we'll get x squared. So in other words, I'm taking out the denominator of 5. So 1/5, all of that's coming out. So this will just become 3x, and this will become minus 28. From here, we're going to factor the trinomial. So two things that multiply to negative 28 and add up to 3. That would give us 7 and negative 4. And we set each factor equal to 0. And solve. So because I only have each equation once, that tells me I'm going to get a unique solution. So all of these are only going to have a multiplicity of 1 because I'm going to get different numbers. So here, when I multiply both sides by 5, I get x equals 0. Here, minus 7, we get negative 7. Add 4, we get 4. And then you can write multiplicity of 1 for all. And again, we'll go over what that means in terms of helping us sketch in class. Okay. The next one I want to do, so we're still going to be finding zeros. These first two both had factoring abilities. This next one we're not going to be able to factor, so we're going to practice using something you might have not used in a while to help you solve for x. So on this one, I'm going to start by trying to factor because if we can, that's easiest. So I make this 0, and I look to see if there's anything in common. Well, they all can be divided by 4x, so I'm going to take out a 4x. But now here's the problem. This doesn't factor any further. So I take my two equations and set them equal to 0. Here I'll get x equals 0. But here, I need to figure out another way to solve because factoring isn't an option. So there's again a couple ways that we can go about solving. Quadratic formula or completing the square. Either one works. Either one will give you the same answer, just sometimes one's easier than the other. So for here, I'm going to do completing the square. Now if you want to do quadratic formula, you can. But there's a reason I'm doing completing the square, and that's because we're going to have to remember how to do it soon. So I'm going to review it now, and so so it'll start coming back to you. So to complete the square, step 1 was to move over the constant. And we're going to leave an open space. And then we have to add something to both sides. Now what do we add to both sides? b divided by 2 squared, whatever number that gives us. b is our middle term, so negative 4. We're not going to worry about the variable, just the number. So negative 4 divided by 2, that's negative 2. Negative 2 squared is 4. So that means I'm going to add 4 to both sides. So this is telling me what we're adding to both sides. Now the polynomial here is factorable. We can factor it as x minus 2 times x minus 2, or x minus 2 squared, equals 3. That's just me adding those two together. Now we can solve the rest of this using square roots. So I'm going to square root both sides. So plus minus the square root of 3, and then add 2. So 2 plus or minus the square root of 3. So we have 3 answers here. We have x equals 0, 2 plus the square root of 3, and 2 minus the square root of 3, all with a multiplicity of 1. Okay, so again, start with factoring, but if you can't factor, remember you have some other methods to fall back on, completing the square being one of them. The other one is quadratic formula. That one a lot of people remember. If you don't, that's just plugging into the formula x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And you plug in a, b, and c, which are the coefficients of our equation, and simplify. Okay, so if you have any questions on any of those, or if you want to walk through the completing the square process again, we can. Again, I don't care which of these two you use. I just know pretty soon we're going to need to know completing the square or need to remember it. That's why I wanted to make sure we went over it here. So if you have questions about that, just in remembering it, bring those to class. Okay, so before we end for tonight, I did want to go over one example, and that's working backwards, where we're given zeros and we have to write the equation. So given zeros, can you see that? Given zeros, write the equation. Let's see, so this is number 4. I'm going to give you the zeros 5 and negative 1. So when we're working backwards, we have to think about how did we get 5 and negative 1? Well, we got x equals 5 and x equals negative 1. And then you have to think, okay, well, how did the 5 get over there? Well, that's because I moved it over. So I'm going to move it back by subtracting 5 to both sides. So x minus 5 equals 0. So that means x minus 5 was one of my factors. Same thing here, we're going to add 1 to both sides and turn it back into x plus 1 equals 0. So I now also know, whoops, that x plus 1 is one of my factors. So then to write my equation, I can do x minus 5 times x plus 1, and that's taking me back to my equation. To get the original equation, because this is its factored form, we would FOIL it together. X squared minus 4x minus 5. This was your original equation. Then just change the 0 back to y, and we've just done our whole process backwards. So instead of finding the zeros, we start with the zeros and work our way to the equation. So I do want to do one more here with you, and then we're going to do one in class that's similar to a test question, and then we'll call it a night. Okay, this one, we're given 0 and negative 2, and told that negative 2 has a multiplicity of 2. So again, that multiplicity means we got that answer twice. So just like before, I'm going to take each of my factors and set them equal to x, or each of my zeros and set them equal to x. And I'm actually going to write this one twice because it's a multiplicity of 2. So here, it's already equal to 0. We have nothing to solve. So that means x was a factor. Here, I have to add 2 to both sides. So x plus 2 equals 0. That tells me x plus 2 was a factor. And then again over here, we add 2 to both sides equals 0. That means x plus 2 was another factor. So if I take my 3 factors that I know and multiply them back together, so I would get x times x squared plus 4x plus 4, and then distribute the x, so x to the third, 4x squared plus 4x equals 0. Whoops, forgot the x there. That would be, change that to a y, and you have your equation. So in class, because this is kind of a big set of notes. So in class, I have another solving if we need to practice more solving. I have another writing the equation given the zeros. And then we have about 3 graphs that I want to go over sketching. Okay, so if you have any questions about the solving or the writing of equations given zeros, come with those ready, and then we'll go over the last few examples before you start your homework.